Hello EarthLab, hello class, my name is Stepan Bryleev and here is my final project called Post-wildfire Vegetation Regrowth Analysis after the Chimney Tops 2 fire in Great Smoky Mountains National Park. In late November 2016, a forest fire started on Chimney Tops Mountain in Great Smoky Mountains National Park. Due to unseasonably dry and windy conditions, the fire spread uncontrollably throughout the park towards the town of Gatlinburg and caused major destruction and fatalities. The Chimney Tops 2 fire was recorded as the largest fire in Great Smoky Mountains National Park history. Wildfires, such as the Chimney Tops 2, are becoming more frequent and more intense, so there is a greater need to study their consequences and post-fire ecological changes. Therefore, we set the following goals: to determine a post-fire decrease in canopy height and track the regrowth dynamics, calculate pre- and post-fire vegetation indices, perform all the analysis in Google Earth Engine and write a tutorial for the NEON Learning Hub. To estimate post-fire changes and recovery rates, a study area of 36 square kilometers was defined inside the fire perimeter. First, canopy height models for pre-fire and post-fire NEON LiDAR data were used to understand ecosystem structural changes within the study area. Then we calculated pre- and post-fire vegetation indices using NEON and Landsat 8 reflectance data. And finally, difference vegetation indices were calculated to classify wildfire severity as well as vegetation regrowth. Let's look at the canopy height changes within the study area between 2016 and 2017 on the left. A large part of the study area experienced significant loss of canopy height the year after the fire, in some places up to 6 meters and more. Now let's look at the regrowth. On the right, the canopy height difference between 2017 and 2021 shows that the canopy height increased by more than 3 meters in some areas after the fire, but in the southern part of the study area it still shows a decrease. Generally, the image of difference between 2016 and 2021 appeared from the right shows that despite the gradual regrowth of vegetation, the fire scar still influenced local ecosystem structure in 2021. And what about vegetation indices? The DNBR image between 2016 and 2017 on the left shows that the fire impact on the forest ecosystem was substantial. Many areas exhibited from moderate to high fire severity using the classification defined by the United Nations. On the right, the DNBR image between 2016 and 2021 shows that in 2021 the post-fire scar was almost completely covered with new vegetation. However, a couple of slower regrowth zones are observed. The temporal data coverage provided by Landsat 8 allowed us to use the most recent observation data from 2023. So let's have a look at the Landsat data from 2015 to 2023. On the left, the DNBR image between 2015 and 2017 shows similar patterns to what we saw with the NEON data for the first year after the fire. And on the right, the DNBR image between 2015 and 2023 shows that the same slower regrowth zones as seen in the NEON data are visible in the post-fire DNBR Landsat data until present. Similar spatial distribution patterns are also observed for other calculated indices such as NDVI and NDMI. The time series of the annual indices mean values also show the impact of the fire event as well as the post-fire recovery. However, reforestation is a long process and the species that are growing in the burn scar are probably early succession species like grass or shrubs. That is why next steps could be to estimate vegetation species composition change after a wildfire, to determine factors affecting forest recovery rates in the identified slower regrowth zones, and to supplement NEON data time series with new airborne observations published in Google Earth Engine. In sum, we can conclude that Google Earth Engine is a powerful tool for visualizing and analyzing landscape changes. Based on materials used in this study, a tutorial was created on NEON's Learning Hub. So to learn more about our forest recovery project, use links shown on this slide. Lastly, I'd like to acknowledge Bridget Haas and John Musinski from NEON for supervising this project. And I'd like to thank EarthLab and Dr. Elsa Koller for teaching us new research methods, and my classmates for providing useful feedback to improve my project. Thanks everyone, and I'm happy to answer any questions.